everyone, my name is Emily. I am an ARPA-E Fellow here at the agency, and I'm really excited to talk to you all today and share some exciting updates from one of our SEED performers. You may or may not know, but SEED is ARPA-E's funding grant mechanism to specifically target small businesses looking to expand their activities in novel energies and technologies. So today I have here with me Ayyoub. Ayyoub works with in the company Ultrasonic Technology Solutions, and they've been developing some really cool technologies. But I won't I won't talk for him. So Ayyoub, can you give us a little bit of an introduction, who you are, and what does Ultrasonic Technology Solutions targeting?
Thanks for having me here. This is very exciting. Let me introduce myself. I'm Ayyoub Momen, the founder and CEO of Ultrasonic Technology Solutions. The goal of our company is to transform the drawing industry.
So what in your background inspired you to do this project?
I have got my master, PhD, and postdoc degrees in mechanical and aerospace engineering from the University of Florida, Gainesville, Florida. So I'm a gator. I hope you are a fan of gators. I don't know. I used to work at Oak Ridge National Laboratory, managing HVAC appliances and water heating program. We had an excellent team of more than 25 scientists and invented so many new and novel technologies. As a matter of fact, one of the technologies that I was involved with, me and my team actually invented this direct contact ultrasonic drawing. As the technology improved over the years, I decided to commercialize the technology, and after licensing it from Oak Ridge, I launched Ultrasonic Technology Solutions, and mid-2020, I decided actually to leave Oak Ridge to fully dedicate my time to the commercialization activity of this technology.
So you're in the lab and you're saying, man, this is too good not to scale up. So we're gonna start actually working on this for real, right? But can you kind of talk a little bit about how does this technology work?
Probably you have seen animals, or let's say a dog, when it jumps into the river or in the water, the first thing it does.
Animals, right?
Yeah. Here you go. When they go actually. Yeah, that's a mother nature, right? When they go into the water, the first thing they do when they come out is that they are shaking their body very hard. And by that shaking, they repel a lot of moisture mechanically. So that was very inspiring for us. We said, can we actually intensify that process? That's how the idea initiated. So the idea we come up with is that if we put a wet material on top of piezoelectric transducers, these are certain a unique type of ceramic material. When you are energizing them, they vibrate at very high frequency in micrometer scale, I would say. So when we put wet material on top of these shaking or vibrating piezoelectric transducers, what will happen is that the water is coming out of the material in the form of cold mist. And that cold mist can be captured, recycled, or vented out, depending on the application. Since we are not heating the material or evaporating water, the process is very efficient and also very fast.
So I guess what's some kind of the potential impact when you were thinking about this technology? Can you kind of give us a sense of how big of an energy sink are these drying processes and how your technology impacts that?
The impact is significant, actually. 1.1% of US GDP, or about 15% of the energy used in the United States, goes to the energy expense associated with drying. These numbers might be shockingly large, right? 1.1% of US GDP is huge number. The reason for that is that a lot of material around you, like starting with a piece of paper, right, that you are writing on, or a tissue, textile material. I'm sure you do have laundry at home, right? A lot of building material like drywall, ceiling tile, gypsum board, pharmaceutical material, food and chemical processes. All these materials around us, or the majority of them, during their manufacturing, they have gone through one or couple of actually drawing processes, and all those numbers adds up to this 15%. The issue is that the existing technology is based on energy intensive evaporation based drawing. Because if you remember in high school, if you want to evaporate water, you have to overcome the latent heat of evaporation of water. So you have to dump a lot of energy into the system. That's why it's not very efficient process. So instead of that, we are not evaporating water. And the novelty of our technology is that we are bypassing that phase change process. Instead of evaporating it, we are shaking it out and just bring the water out of the material mechanically. By doing that, we can improve, definitely depending on the type of the material we are drawing, but we can improve the efficiency of the drawing by a factor of 5. And we can dry the material actually at least 2 times faster. When this technology hits the market, it can transform the drawing industry, saving a lot of energy and significantly reducing the carbon footprint, embodied carbon of different products around us, and also creating a lot of new manufacturing jobs.
What are you hoping, or where do you hope to take this technology in the next 5 to 10 years?
We have had an excellent experience with ARPA-E and the program managers and the team. Their support at the earliest stage of the technology development significantly help us to solve some of the key challenges associated with the scale-up, enabling us to make a mid-scale conveyor belt ultrasonic dryer that was 12 feet long, 1 feet wide, and it was designed specifically for textile industry. In the next 5 years, we would like to see our industrial dryer or machinery being demonstrated and used in a couple of industrial sectors. In 10 years time frame, we would like to transform the entire industry. Our goal, or my goal, is that in the next generation, when they look back at drawing technology, I would like them to see how much improvement is being made on the technology, on the drawing technology, and hopefully the next generation could use a better, more environmentally friendly drawing process.
Really, Ayyoub, it's been an honor and a pleasure to kind of sit in on your team update meetings and listen to all the progress that you all have been making. And that kind of brings me to my last question. What was it like to work with ARPA-E as a small business? And maybe what kind of advice do you have for other small businesses who are looking to maximize this opportunity?
We have had an excellent experience with ARPA-E and the program managers and the team. They are very professional. They were very professional, knowledgeable, and their feedback actually really help us help the progress of the project and the technology. I would say without ARPA-E's help and support, we could not be here. And for that reason, I'm very thankful of ARPA-E team. My advice is not too afraid to setting up big goals. Big goals actually really help you to improve the productivity of your team and achieve your goals faster, going through cycle of innovations much faster.
It's been a privilege and a pleasure to talk to you today about the awesome technologies. I knew that you guys were a perfect example of what a seed grant can do at ARPA-E. And just as a reminder to the folks who are watching this energy brief, the seed program is specifically for small businesses who are looking to scale their technologies or develop new technologies in the energy space. More information can be found on the ARPA-E website as well, and we'll be publishing a series of energy briefs to also highlight other teams who are doing amazing things with their seed grants. So thank you again so much, Ayyoub, and it was a real pleasure talking to you today.
It was great talking to you today.